Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving into a fascinating discovery about bacteria and polymers. It's all about how bacteria create these incredible, cable-like structures within polymer solutions. Like, mucus. It's pretty wild.
Whoa, bacteria building cables? That sounds unexpected. What's the mechanism behind this?
So researchers at Caltech and Princeton found that when bacteria, like E. coli, grow in a polymer solution, think mucus in the lungs, they don't just swim around independently. Instead, they form these long, cable-like structures. These cables intertwine, creating a kind of living gel. It's like a living jello. Amazing, right?
A living jello. That's a great analogy. But why do they do this? Is it a deliberate strategy?
That's the million-dollar question. The researchers aren't entirely sure yet. One theory is that it's a defense mechanism. By clumping together, the bacteria become larger and harder for the immune system to eliminate. But there's another possibility.
Oh? What's the other possibility?
It could actually be detrimental to the bacteria. See, mucus isn't static. It's constantly moving, especially in the lungs. So, being clumped together in these cables might actually make it easier for the body to expel them. It's a bit of a paradox, isn't it?
It is! So it's a bit of a mystery still. But this discovery has implications beyond just cystic fibrosis, right?
Absolutely. This research is relevant to understanding biofilms, those sticky bacterial communities you find everywhere, from river rocks to dental plaque. The same principles of polymer interaction seem to apply. Understanding how these cables form could be key to developing new ways to fight infections and control biofilms.
That's huge! So the physics of how these cables form is also significant?
Yes. The researchers found that the pressure from the surrounding polymers forces the cells together. It's a depletion interaction, a concept from polymer physics. They even created a model that can predict when these cables will form. It's a beautiful example of how principles from seemingly unrelated fields can illuminate biological processes.
This is incredibly interdisciplinary. It bridges chemical engineering, bioengineering, biophysics, and even polymer physics. It's truly remarkable how this research connects so many different areas. I'm curious, what kind of polymers are we talking about here? Are they all organic?
Good question. The initial studies used mucus, which is an organic polymer, but they also saw the same cable formation with synthetic polymers, suggesting that the underlying mechanism is quite general. It's not specific to a particular type of polymer.
That's fascinating. So the next steps are to figure out whether cable formation is beneficial or harmful to the bacteria, and to explore the implications for treating infections and controlling biofilms. This research opens up a whole new avenue of investigation.
Exactly. It's a really exciting area of research, and this is just the beginning. We've only scratched the surface of understanding the implications of this discovery. It's a testament to the power of interdisciplinary research and the unexpected wonders we can uncover when we look closely at the natural world. Thanks for joining us on Tech Bytes and News. We hope you enjoyed this deep dive into the world of bacterial cables and living gels. Goodbye, and have a great day.
Bye-bye.